What we are going to talk about is the relationship between internal energy, heat, and work. First of all, what is internal energy? This is how Wikipedia defines internal energy. It's basically the sum of kinetic energy of each molecule and potential energy between the neighboring molecules. Change of internal energy equals thermal energy transferred to the object, added by work done on it. Both of the quantities can be calculated by the following formulas. Another thing to be noticed is that there are two ways of doing work. One is exerting forces, the other is charging the object. Now let's talk about energy change by heat. When we heat a beaker filled with water, the temperature shown on thermometer will increase continuously. From previous knowledge, we know that temperature is a measurement of the average kinetic energy of water molecules. So the increase of temperature means the water is gaining kinetic energy, and has more internal energy. In this case, no work has been done on water inside the beaker, so the change of internal energy equals mc delta theta. As the other factor affecting internal energy, potential energy is given by intermolecular force and intermolecular force, which won't be discussed in detail in our presentation. Do you remember the experiment Richard did with a plunger last week? He put some cotton at the bottom and exerted a great force at the top. Air inside the tube is suddenly compressed, so the internal energy increases, causing the temperature reaches the point of combustion of the cotton. Then, in theory, fire will be observed. Well, if the force is too large, what happens instead of burning will be exploding, just the same as what did happen last week. Steam engine is another example of the transfers between heat and work. It's too difficult to draw this on our own, so we use this short video. Water is heated up to its boiling point and then steam is produced. The internal energy of the system increases, which will be further transferred into work done on the pump. In this process, the internal energy is transferred from heat to mechanical energy. The last part of our presentation is a brief introduction on work done by current. For this experiment, we could connect a battery across the screw. After a short while, if we take the screw out of the circuit, it will get warmer, which means its internal energy increases. In this case, energy has been transferred electrically by the cell exerting a force on the electron charge carried in the screw. This force multiplied by the distance moved by the electrons will give the amount of energy transferred to the internal energy. That's all for our presentation. Thank you for your patience.